Okay, so this next drawing is to do a 2-point perspective drawing of boxes floating in space. And the first thing we want to do is ensure that we have the right tools. So we're going to be using a 6H pencil. This is going to be essentially part one, where you're just going to get everything sort of drawn in and get the basic mechanics of how it is that we're going to develop this drawing. So the first thing that we need for a 2-point perspective drawing before we go any further is to establish an eye level. Halfway is a nice place to start, but I'm going to change things up a little bit so that the drawing is a little bit more interesting. And since we want sort of things floating in that space, I want to break up the space so it's not just cut in half. So in this case, I'm going to go maybe to 4.5. So this will hopefully make my composition a little bit more interesting, so that things are not ending up equally spaced out above and below my eye level. So just like 1-point perspective, 2-point perspective uses the eye level to establish either a horizon, but what it actually means is your frame of reference or your actual eye level, your location in space. So when we're dealing with 2-point perspective, ideally we want the points outside of our image space. Those points refer to the cone of vision. So that's an imaginary cone where we can clearly focus on things, and in order to make that sort of mathematical equation, we use those points, and those would be the furthest most points that this mathematical equation will function. Beyond that, things start to lose their sense of believability. We're not making things real, we're making things appear believable in this space. So in order to make that happen, we're going to have 2 vanishing points, and we're going to put them as far out to the edges so that we have the most amount of drawing space as possible. So this will be VP1. That's a very standard way of describing these. So VP stands for vanishing point 1, and this is for explanation purposes. And then the other point as far out to the edge as possible, VP2. You don't have to do this for everything that you do, but it's good to sort of establish that, especially when there's an explanation happening. So a little bit different than a 1-point perspective. In 2-point perspective, what we're dealing with is the corner of an object, and then this corner, what happens is this is the part that's closest to us. Everything else is much further away, so it's receding away from us. Instead of the straight plane or the face that we see on a 1-point, on a 2-point, what we see that's closest to us, this is the thing that's closest to me here, it's closest to the camera. In 1-point, this is closest. In 2-point, this corner is closest. So that's the first line that we want to describe, not the square or rectangle, but this line that indicates the corner of this box. Okay, so once we've established that corner, then we want to create orthogonal lines vanishing to each one of those vanishing points. It's a good way to, especially when you're starting out, to always go to vanishing point 1 and then go to vanishing point 2. And then that'll keep the system sort of functioning until you get a hang of it. And then you can start inventing your own boxes floating in space, and how you go about it and how you sort of dissect it or make that box grow will be up to you. But first is to establish the sense of this box is existing in space. The reason we use boxes to establish the sense of believability of perspective is so that you have a frame of reference and you have the ability to then establish anything in space, and even something as complex as, for instance, a hand. I could then place each one of these segments of my hand into a box, plot it in perspective, and then be able to draw it from imagination in any direction that I want, so long as I understand the volume and I can envision a box sitting within this sort of organic form, right? So we're going to create some simple geometric forms, and those forms will begin with boxes, and then we'll become more complex by how we edit those boxes, and those will be your letter forms. So we're gonna first start with the vertical line, right? So I'm using again this line here, goes all the way across on my ruler. Also, it's good to know your ruler. Not all rulers do this, but this one happens to be made in such a way that these longer lines match up. The other thing is that this ruler starts at a 0 on edge. Some rulers have a little bit of space, so make sure that you pay attention to what kind of ruler you have so that you're using the ruler properly and taking the most advantage of it. So in this case, this long line is helping me balance this out to make sure that I have a 90-degree angle here. So I'm just going to make a box. This seems like this is a good distance, right? So that's my first line. I'm going to establish the top and bottom of that box to make sure that I know exactly where to start directing these lines. Because we're doing is very fluidly, it's not necessary that you measure, but it is necessary that you make some marks so that you know where you're starting and you know where you're ending. And that'll be a reoccurring theme in drawing from observation. The idea with all of these things is that you understand how all of these volumes function, and then how to make it look more visually appealing as you get more comfortable with the drawings. However, you have this theory behind it in case you get stuck when you're doing things a little bit more loosely. So now that I have these orthogonal lines, I need to establish the end of my box. So where my box is going to stop. I'm going to just arbitrarily decide to stop it there and arbitrarily decide to stop it here. Right? So that means that from this corner, opposite of VP1, right, I'm going to go to VP1. So opposite of VP1 goes to VP1. Right? Opposite of VP2 goes to VP2. And I'm going to stop there. Also forgot to do the vertical lines. All right, so now I have a box. So these vertical lines in this drawing are the only things parallel to one another. These three lines converge to VP1. And these converge to VP2. Right? So these are converging back that way, these are converging back that way. This one, if this box was transparent, this, just like this, it's opposite of VP1, must go to VP1. So now we're going to make a transparent box. And then this corner, right, the bottom of this vertical, is now going to VP2 because it's opposite of VP2. That's the easiest way I can sort of think about it. And I'm going to stop at the end of that and then drop a vertical from there. And that's a transparent box in space. So, box below the eye level, we'll do one maybe here at the eye level where we can't see the top or bottom of that box. And again, we'll start with the corner. Then we'll establish the top and bottom of this box. This one's a little taller. goes there. And this goes to the opposite side. Establish where the box ends. And there. I won't forget to make the verticals this time. And establish your vertical line first. And all we are able to see is two sides of this box, because where our eye is here, we cannot see above it and we cannot see below it. Right? Even if it's floating, we can't see on top or below because our eyes are essentially here. And we're unable to see above that. This becomes really important once we start actually looking at objects in space and in real space instead of inventing, and it forces us to stop trying to see what we don't see and draw or move around to try to draw what we are not able to actually see. So if we're doing this box transparently, or we're going to use it as a construction to then create letter forms, we're going to have to know where the end or the back side of this box is. So we have to make this transparent for that purpose, and only for that purpose. Otherwise you can make a solid box and that's all you would need. So this will go back that way. Again, it's opposite side. Goes in that direction. The opposite corner goes to VP2. Okay, so for getting more complex, there's other videos how to break this down further, but this is essentially the process for making floating boxes in space.